The German design for the euro had more metal on one side than the other. Hans thinks that this makes the coin biased. Remember, a fair coin has a probability of a half for getting a head. You're equally likely to get a head or a tail. Saying the coin is biased means that this is no longer true. What could he do to find out? What he could do is perform an experiment. He can collect information as shown. He can record the number of tosses. He can record the number of heads. And to estimate his probability, he can record something called relative frequency. This is equal to the number of heads divided by the number of tosses. So the number of times the event has occurred divided by the total number of trials. So let's say he does the first toss, and it's a head. The relative frequency is 1. The relative frequency is our estimate of the probability. So at this stage he's saying that it's certain he's going to get a head every time. Then he does the second toss. This is not a head, so he still only has one head. 1 divided by 2 is a half, or 0.5 as a decimal. So at this stage the relative frequency is telling us it's equally likely to get a head or a tail. When he does the third toss, he gets another head. The relative frequency is 2 divided by 3, which is 2/3. The idea is to do lots of trials. And the reason for this is that, as we saw with these first few trials, the estimate of the probability, the relative frequency, fluctuates wildly. This effect becomes smoothed out as we increase the number of trials. So to get our best estimate of the probability, we want to do lots of trials. In practice, how can we do this? Well, if we perform the experiment in class, we could get everybody to participate. If everyone in the class tosses a coin lots and lots of times and we pool the results, then we have a lot of data to work with.